Lesson 6 is more of dealing with quadratics and solving for a variable with an equation. So the lesson, again, the homework is in your packet. It's not problems 1 through 4 or 7. I fixed that. But we're still going to be talking about the zero property and just solving an equation, but looking more at like real world examples. So if we were to have our do now, my problem is a physics teacher put a ball at the top of a ramp and let it roll down towards the floor. So right here, the class determined that the height of the ball could be represented by the equation h equals negative 16t squared plus 4, where height is measured in feet from the ground and time in t seconds. So just looking at this equation, it's a quadratic, but this plus 4, if you might notice, it's kind of looks like our plus b when we think about something that's linear. So it's actually like our height or like our starting point. So technically this ball is already 4 feet high in the air, right? We're already noticing that it's not on this ground level. If it was on ground level, we'd be starting at a height of 0, but we're not. So we're starting at a plus 4 height. What would you think the negative 16 would mean? Well, the ball is going down, so we know if we have a negative rate, and it's being multiplied by that time squared, okay? So in that equation, the 4 is the initial height. What would you use the equation to determine what the time it takes the ball to reach the floor? Well, if it's going to reach the floor, then that value, that height of that ball, right, that h value, right, the height is this equation, has to be 0, right? When the ball gets to the floor over here, the height is now going from 4 maybe to 3 to 2 to 1 to 3.4. It's going down, right? So down here, we get a height of 0. So that's why we're equaling our equation to 0 here. So they're asking you to find the solutions. At what time could the ball be at this height of 0? Okay, so you're seeing, we have this equation. We're solving now here to get the time. Okay, remember that it said the height equals this equation. So if we want to know the time it is on the floor, this is where, this is 0 feet. This is where the height of that ball is going to be. All right, we have a plus 4 minus 4 from both sides. Okay, we get a negative 4 here equals a negative 16t squared. We got to get t by itself. Divided by negative 16 on both sides. A negative divided by negative is a positive 1/4. We're left with t squared is 1/4. How do you get t by itself? You take the square root. Okay. So now you're seeing when you take the square root, again, we've talked about this, it could be positive or negative, right? If you take the square root of 25, the square root of 25 is 5, right? 5 squared is 25, but negative 5 squared can also be 25. So these values can be positive or negative. But why do you think we reject this negative 1/2 as time? T is time. Can you have a negative time? No. So the t can only be a positive half. In our case, t was seconds, so it'd be like half a second. That's how fast that ball is rolling down, and that kind of makes sense. If it's on a slope, a ball can roll pretty fast, and so on. Okay. We have another word problem here you can read through. So basically, we're designing a garden. They're saying the minimum size of the garden can be, one side will be a minimum of 2 plus this value of x. So if the length is 2 plus x, and we're talking about a square, you should know that all sides of a square are the same. So length and width are the same. How do you find area? You're multiplying these two together. And remember, when you distribute, we've done this in the beginning before we left to come home, we have those values there. Okay, there are 12 families in the kingdom who are interested. So if you have the value of one garden, you can multiply by 12 to get the whole